Hello everyone, I hope you all are doing great. In today's video, I'm going to describe about the electronic configuration. Let's discuss the definition first. Electronic configuration is the arrangement how electrons are distributed in its atomic orbital. Basically, when we study the periodic table, we are find out that atomic number 1 we have describe it in for some kind of sequence or some kind of electronic arrangements. So basically that electronic arrangement is called the electronic configuration. And another thing is that in order to describe the electronic configuration, we are going to use the standard notation like as for 1s, 2s, 2p, 3s, 3p, 3d. See, these are called as a standard notation in order for describing the electronic configuration. The another thing is that these atomic subshells are arranged in sequence. This sequence can be easily be memorized or can be easily be designed with the help of this diagram. Basically, in order to get the electronic configuration, you have to describe the orbitals like as it described in this picture. 1s, 2s, 3s, 4s, 5s, 6s, 7s. We are stop here that because we have only 7 periods in our periodic table. That's why we stop at 7. And after that we are going to consider only those orbitals which are enough for in order to design the electronic configuration of 110 elements. So as we know that in the previous video I have described you about that n is equals to 1 means only one suborbital is present in it. So suborbital is starting from s orbital, p, d, f. So first orbital is s orbital, so only one, that is 1s. And 2 n is equals to 2 means there are possibility of 2 orbitals after p. 2s, 2p, then 3s, 3p, 3d. In the similar way we are designing this electronic configuration, and the arrow shows here firstly 1s, after that single arrow 2s, then 2p, 3s, right, 3p, 4s, 3d, 4p, 5s, which are come in the same arrow. They are come in the downward side like as 3d, then 4p, then 5s, then 4d, then 5p, then 6s. In this way you are able to get that sequence in order to fill the electronic configuration. Now next part is come into our discussion is how you are going to use this electronic configuration. We are use this electronic configuration to fill the electron. Why we fill the electron? Because in order to describe the atomic number like as atomic number 10, how we are able to describe in the form of electronic configuration with the help of this method. Firstly, whenever you start filling the electron, you have to start the electron filling from the very extreme orbital. The very extreme orbital or the very first orbital is 1s. Whenever you start filling, you are not get confused at any other how you are going to start your electronic configuration filling. So you are going to fill the electron first in the 1s orbital. Then another rule is come into your discussion is Hund's rule. Every orbital in sub-level is singly occupied before any orbital is doubly occupied. This can be understood with the help of this diagram as I chose for discussion. Look at here. 1s is only single orbital. That means there is no other orbital present whose energy is similar to 1s, right? So if the look at the diagram further at 2p orbital, as we discussed in previous video that p is further divided into 3 orbitals, that is px, py, pz. So these means these orbitals have similar energy. So that's why we call the term degeneracy. The orbital whose energy is similar, we call it as degenerate orbitals. The Hund's rule state that whenever we start filling in the electrons in the degenerate orbitals, means the similar energy orbitals, firstly we have to singly fill them, and after that we have to pair them. Like as in this diagram there are 3 possible scenarios. They have this, only consider the 2p orbitals for your clarification of Hund's rule. First case, 2p orbital has three degenerate orbitals. The three orbitals will be filled in the single way, like as firstly singly filled orbitals. The second possibility, they describe that they fill the two electrons in first orbital and the remaining of one electron in the second orbital. And the third possibility is they have filled the three electrons in different three orbitals but with the opposite spin in the middle of one. So out of all these, most probable means the way you are able to find the electron density of the that particular element. This is the most preferable case, that whenever you fill the singly orbital, you are always prefer upward spin, right? So in the third diagram, they have tried to fill the electrons in singly filled electrons, but they are right at that point. But one of the electron they have having opposite spin. That's why we ruled out this third probability, right? The another orbital is Pauli's exclusion principle. Pauli's exclusion principle states us that no two electrons are present in the same orbital. Like as consider in the first diagram, in 1s orbital there are two electrons filled, 2s orbital there are again two electrons are filled. But the difference is in 1s orbital, one electron have upward spin and the second electron have downward spin. But in this 2s orbital, both the electrons have parallel spin, which is never possible. Right? This is the Pauli's exclusion principle, who states that whenever you fill the two electrons in the same orbital, make sure that the electrons present in that orbital have no four quantum numbers are similar. Now the term come into your mind is, what are quantum numbers? As this topic is needs some another more detailed discussion, but I don't consider in this video. So basically I'll describe only the name of these four quantum numbers and basic knowledge about them. Principal quantum number, how you able to find out the principal quantum number is, let's consider the 1s orbital. Here 1 is called as n is equals to 1, where is n is a principal quantum number, which describes us that this electron belongs to K shell, right? Azimuthal quantum number is S or P, which helps us to find out the further atomic orbital of that. What is the formula of that? N minus 1 means 1s orbital means in order to find out what are the atomic orbitals, suppose 1, you only know the 1, n is equals to 1. So 1 minus 1 is equals to 0. 0 means s orbital. That means for next azimuthal quantum numbers, you have to get into the picture that orbital become 1s, right? 2 is equals to n is equals to 2 means l is equals to n minus 1. So 2 minus 1, that is 1 till 0. 0 you have to move to 0. So 1 or 0. L is equals to 1 means p orbital. L is equals to 0 means s orbital. That's why n is equals to 2 have two atomic orbital. First is 2s and second one is 2p. Third is magnetic quantum number. This is quite easy. Whenever you get the L value, you have to just describe the range, that is minus L to L. If you find out the L is equals to 1, that means ML will be minus 1 to 1. And the spin quantum number, there are only two spins are possible, whether electron will be moved clockwise spin or whether it moves to anti-clockwise spin. If you observe that the electron during filling, the electron direction is upward, then we call it as clockwise spin, and if it is in downward direction, we call it as anti-clockwise spin. Now let's practice the examples which are for the related to your electronic configuration. Now chlorine atom, it's quite convenient if you remember the first 30 elements of the periodic table, so as to become familiar with the basics of chemistry. So chlorine atom atomic number is 17. Now we have to start the electronic configuration from the scratch, like as 1s, 2s, 3s, 3p, 3d. Now start filling the electrons. How you start filling the electrons? Consider my previous video. As I described in that video, that s orbital is able to accommodate only 2 electrons, p orbital is able to accommodate 6 electrons, d orbital is able to accommodate 10 electrons, and f orbital is able to accommodate 14 electrons. In order to fill the electronic configuration, you have to remember that concept. So start 1s, 2s, 3s, 3p. Now in superscript you have to mention the electrons. 1s is able to accommodate only 2 electrons. 2s is able to accommodate only 2. 3s is able to accommodate only 2 orbitals, 2 electrons, sorry. And 3p is able to accommodate 6 electrons at maximum, but electronic configuration is finished at 5. Here I forgot to mention one electronic configuration, that is 2p6, 1s2, 2s2, 2p6, 3s2, 3p5. That's my mistake. So another thing is 2s, 1s2, 2s2, 2p6. This is correct one. Yeah, you have to consider the chlorine electronic configuration. Let's total the 17 electrons. Whenever you fill any electronic configuration, make sure that you count the total electrons at end. So to ensure that whether you are right or wrong. In the similar way, iron, again one thing is missing, 2p6 is missing. So you fill that 2p6 electron, 3s2, 3p6, 4s2, 3d6. See, in short way, you are going to mention only noble gas configuration, then 4s2, 3d6. In order to create this video, I have referred this book as a reference. Thank you so much.